Hey everyone, and welcome. Today we're jumping into the science of what makes software fast. We're going to break down the two major ways engineers make sure the apps you use are not just speedy and reliable, but that they don't completely fall apart under pressure. We're talking static versus dynamic performance testing. So let's kick things off with a question that, we've all been there. Why is it that some apps just feel incredibly smooth and responsive, while others are just slow, buggy, or worse, they crash right when you need them most? Well, the secret isn't just about good coding, it's about how that code was tested, both before it was ever written and after it was running. And that, right there, is where performance testing comes into the picture. At its heart, it's the whole discipline of making sure software doesn't just work, but that it performs beautifully under real-world conditions. It's all about making things stable, fast, and responsive. Now, this isn't just one single thing you do, it's really a whole bunch of strategies that are designed to see how an application holds up when, say, thousands of people are using it at once, or when it's running on different phones and computers. The whole point is to find an app's breaking points in a safe, controlled way long before your actual users find them out in the wild. And the very first place you start looking is in the design itself. Okay, first up, we've got static testing. The best way to think about this is like an architect checking the blueprints for a skyscraper. They're looking for fundamental design flaws, things that could be a total disaster later on before a single piece of steel is even in the ground. That is exactly what static testing does, but for software. And here's the critical part. Static testing happens before the system is running. I mean, not a single line of code is actually being executed. Instead, we're combing through design documents, architecture diagrams, and requirements to spot potential problems on paper. And this quote from our source material really hits the nail on the head. It says, "Many critical performance defects are introduced in the architecture and design of the system." It's just so true. If you build on a shaky foundation, it doesn't matter how fancy the rest of it is, you're going to have problems. So what does this blueprint check actually look like? Well, it's things like reviewing the initial requirements to spot performance risks from day one. It's analyzing the database structure to make sure it's efficient. It's looking at the whole system architecture for bottlenecks. You might even review supercritical pieces of code, like a complex algorithm, to make sure it's not going to be a resource hog. All of this before the thing is even built. All right, let's flip the coin. If static testing is checking the blueprints, then dynamic testing is the real-world stress test. The building is up, and now we're going to push it and pull it and see if it can actually handle the strain. So here's the big difference. Dynamic testing happens on a live running system. We are absolutely executing the code, we're simulating users, we're throwing data at it, and we're measuring how the software actually behaves in real time. This is all about performance in action. And dynamic testing isn't just a single event. It's more like a journey that gets bigger as you go. It starts small, with developers profiling individual bits of code to see if any are slow. Then you move up, testing how key workflows perform when they're all connected. From there, you test how the whole system talks to other systems. And finally, you get to the big one, tuning the entire application in an environment that looks just like the real thing before it ever goes live. So, you've got the blueprint check and you've got the stress test. And listen, it is not a question of which one is better. The truth is, you absolutely have to have both of them working together if you want to build truly high-performance software. In fact, this whole two-sided approach is basically the industry standard. Our source for this? The ISTQB. And you can think of them as the people who literally write the rulebook for software testing globally. Well, their entire framework for performance is built on this core idea of separating static and dynamic methods. They know you have to check the design and test the real thing. And this chart really makes it crystal clear. Think of it like this. Static testing is proactive. You're finding flaws in the blueprint before you even start building. Dynamic testing is reactive. It's about finding weaknesses in the actual building while it's in use. One prevents problems in theory, the other discovers them in practice. Okay, so we've looked at both sides of the coin. After everything we've talked about, what's the one big idea you should take away from all this? It's this. Amazing high-performing software doesn't just happen by magic. It is carefully designed that way from the very first sketch using static analysis, and then it is relentlessly validated as it's being built with dynamic testing. You need both. You need that solid foundation and you need the real-world resilience to get it right.
So, I'll leave you with this to think about. In today's world of super fast, agile development, where we're shipping new features every week or even every single day, which one of these do you think is becoming more critical? Is it that upfront blueprint check to stop flaws from ever happening? Or is it the constant stress test to catch them the moment they pop up? That's a huge debate in engineering right now. Thanks for tuning in.